Thank you for introducing me. First, I want to thank Mats Lindmark for the opportunity to invite me to this first EuroNOG event. Well, the slide is telling me, telling that I'm Peter Paul Engelen. I'm working from EDPNet. We are. First, I want to tell you some quick facts about EDPNet. We are an independent telecom provider, founded in '96, headquartered in Sint-Niklaas. This is a small city close to Antwerp. We have other branch offices in St. Pete, in Amsterdam, and in the US. Recently, we registered as an incorporation at the end of March. EDPNet can be seen as a common sense provider. Well, I think it's better to call us a carrier. We are the clever alternative for more monopolistic telecom providers. We provide high quality products and services at an affordable price. I think that's very important to tell you. We are proud of our transcontinental optical network. I think it's the ideal platform for connections between the US, Europe, and Russia. EDPNet's market. EDPNet is in wholesale. We are offering IP transit, DWDM, point-to-point, and voice, and they are especially related to the three continents, Russia, USA, Europe. We also provide internet access, and they are based on the historical networks of Belgacom in Belgium and KPN in the Netherlands. On the other side, we offer internet link products for retail B2B on the three continents. This is our optical network. You see on the left, we are in the US. We have POPs in New York and in Ashburn. Then we have Europe, and we go over the Nordics back to, we can see it now, but into Russia. It's fully redundant, stretching three continents. The network is based on the newest DWDM technology. We have fully redundant POPs, and we can deliver scalable speeds up to 40 gig and more. Out of the way of EDPNet, how do we use route analytics, and what was EDP looking for if we compare it to the solution of packet design? It's Traffic Explorer. Well, we were looking to better data to drive network planning, particularly for analyzing and optimizing transit and peering relationships. We were looking for an IP version 6 ready solution. And we were looking for a standalone package just to have a good integration with our existing applications. Regarding detailed traffic analysis, we were able to check how much traffic was going from us to another party. So we should decide, or we could decide, is it useful to set up a direct link or connection? The Traffic Explorer gives us also a complete overview of the amount of traffic to a main AS or attached sub-ASs. And on the other side, it gave great insights into EDPNet's connection to decide if you should buy transit or peering. EDPNet offers a lot of MPLS services to Russia. The connection Europe-Russian is crucial to our organization. And the combination of routing and traffic analysis gives us also detailed insight into this traffic. Well, it's a pity that we can't use the full screen. This is an overview of the traffic reports out of the Traffic Explorer. It's showing the outgoing traffic to a destination AS on a 5-minute average interval. And then you see we have more than 4,000 entries, and the top level is based on more than 100 Mbps. The next slide is an overview of the total amount of traffic regarding neighbor ASs. On the top, we use more than 450 Mbps for more than 300 entries. This is just a part of the whole list. I just took a screenshot from the top. Regarding network optimization, we can easily detect and track network anomalies, for example, denial of services. Some examples are connection delays, links that are down, or external attacks. The integrated routing and traffic analysis automatically updates the data about our network performance. We can easily check all parameters in real time. This is an overview of the Traffic Explorer within EDPNet, and it's showing that some nodes are down and that the line colored red is shown as an downlink. This is the network summary within the Traffic Explorer, and seeing regarding the several routing protocols. Regarding to check all parameters in time, we zoomed into a Amsterdam router, which is named as a border router, and we see its IP prefixes, and we can check the events within a couple of minutes, hours, and days. So we see also that the state is up at this moment. Regarding the solved issues we had related to hardware. Within EDPNet we have different kind of routers, and for us it was very important to know how to get the right NetFlow data. And the flexible route analytics capability solved this problem. But in the past we had a server crash, and no backup was made, so that was really a problem. But a complete recovery of the data was possible by leveraging our route analytics capability. Regarding end-user benefits, EDPNet can offer high-quality connections, traffic offload via the shorted path routes. We can guarantee lowest latencies, lowest packet loss, and the fastest connection possible. So by gaining better insight into our routing and traffic, we can deliver more effectively on our promises. If you have any questions for services out of the US or Russia, you can always contact me, or please feel free to contact my colleague in Russia. I have some leaflets for you, so if you're real interested in our fiber optic map again, so don't hesitate to ask me. I want to thank you for paying attention to this presentation, and I want to introduce you to Mats Lindmark from Packet Design.
Okay, thank you, Peter. That was good. I'll try to switch a little bit here in the presentations. Just give me 1 minute. better, right? Back to yeah. Okay. So my name is Mats Lindmark. I work for Packet Design in Europe. I'm a systems engineer. So I worked quite a lot also with the installation and fine-tuning of the EDPNet network, as Peter Paul just told us about. So I will tell you a little bit more about Packet Design and what we do, except for the things that Peter already has told you. We are founded in 2003, so we've been around for about 8 years. We have partnerships and solution integration with CA, Cisco, Ericsson, HP, and Juniper. We are the pioneer in route analytics. So with route analytics, we don't have any, I should say, straight competition. There are some bits and pieces that are, in some cases, overlaps with us. But in terms of route analytics, we are the only one doing real-time route analytics solutions. We have about 500 customers worldwide. Most of them are in the ISP carrier arena, but we also have an increasing customer base out of mobile operators, because IP is getting more and more important in the mobile arena. There are also some enterprises that still own their own networks. So we do some enterprise solutions as well. So there is really a gap in the typical network management tools that are out there today. So the applications and the services on the network, you want to do deeper monitoring, faster troubleshooting, and be able to accurately plan your services. Also, these networks today are becoming more and more redundant and more complex, so you can't really tell where is my traffic going at each point in time. So how does really network engineering know which part of the network is actually carrying the application traffic? And where in the network to troubleshoot if things are going wrong? If you want to plan things accurately also in the network, how do you do that from a network-wide point of view? For example, if you want to establish a new link in the network, a new router, or maybe taking a link down, how do you accurately plan for such events, like upgrading a router and so on? So all of these changes to the network is really hard to anticipate what's going to happen with the network. The more complex the network gets, the more hard it is to anticipate things. So typically the application performance monitoring, there are tools for monitoring an end-to-end application performance, but they typically focus on the endpoints of the network, and those tools typically also don't see how the network behaves in real time, or they don't have any history for how the network has behaved in the past. And the traditional SNMP network management typically focuses on network elements, like how is my SDH network element behaving, how is the WDM network element behaving, the switch, the router, and so on. So they typically focus on the elements, and there is really a gap where we need to see how the IP routed network behaves. And this is exactly where we work. So packet design, we work with the IP routing protocols. And that's what we do, IP routing. We monitor all router and link status. We make sure we have control over the paths in the network. And we constantly communicate with the network topology using live routing protocols. So this is a picture of how we actually work. So this is the basis of the foundation of packet design, the Route Explorer. So it's really a routing control plane. So we are like a router in a network. We connect like a router to the network. We use OSPF, ISIS, BGP, multi-protocol BGP, RSVP, all of those kinds of protocols to get as much information as possible from the network. So in this case, you see that the Route Explorer is connected to the OSPF network here in the middle. We just need one connection to one of the routers in one area. And once we have that connection done, we will automatically display the whole topology on the graphical user interface. So we discover the whole network within 5 seconds. And because we are here on the network listening to all of the OSPF and ISIS and BGP events, we do something like is called, we record a routing event history. So we put everything that's coming from the network into our database, which means that we can go back in time and see how is my network behaving 1 hour ago, 2 days ago, 1 year ago. And we can see detailed events about what happened to the network with this event history, as well as real-time view, because we see everything as soon as the router sees something. We are like a router, so we will see everything just when things happens. And because we have this history, we can then use that capability of also simulating things into the future. What happens if I take a link down? What happens if I add traffic, more traffic to a specific VPN customer? Will my links in the network cope with that traffic? Okay. So on top of this routing information that we know, we put traffic information on top of that. So we collect, in addition to collecting like OSPF and BGP stuff, we start to collect net flow information. And the real strength of this product in the net flow is that we don't have to collect net flow from everywhere in the network, because we already know the routing, right? We know that, okay, this core network here, if we collect just from the edges of the network, we can project all traffic to the core network without actually collecting from the core network, because we know the routing and then we can project things. So we actually call that PathAware traffic analysis. So we're merging the traffic analysis information with the routing information that we have. So for example, you can collect this information and say that, okay, what if I take my link down between two routers? Will that cause any effect for my VPN customers? For example, which VPN customers are affected if I take this link down? That's quite hard to determine actually in the core of the network, which P routers are carrying what type of VPN traffic. It takes a lot of going in and using hands-on on a couple of routers to see the MPLS labels for carrying that specific VPN traffic. It's quite hard to do. And we can do that within 2 or 3 clicks from this tool. We can also see exactly what type of traffic these links are carrying. So, for example, in a VPN network, you would be able to see if the between two customer VRFs, you could see, for example, if that customer has VoIP traffic, surf traffic, video traffic, or other types of traffic carrying between two specific VRFs in the network, which is also very, very hard to do. And you can see the exact complete path of that traffic on a VPN. So that part of the tool is called the VPN route analytics. And that's just a software license. So once you have installed the route recorder with the OSPF and ISIS, if you have a VPN, layer 3 VPN network there, you can just add a license and the same route recorder will continue to function as a VPN route recorder and see all of your VPN networks. One of the recent additions we made to the route recorder is something called the TE, Traffic Engineering Explorer. So we can actually analyze RSVP traffic engineering tunnels in the network. So here, for example, you see a little picture where some of the traffic follows the IGP that way, but we have tunnels that divert the traffic over another path in the network. And you can go into vast, very granular details to see this. To see these traffic engineered tunnels, you can see the explicit routed objects, you can see the recorded route objects, exactly which hops the tunnels goes through. And we do support fast reroute, so you can see when your fast reroute tunnels has kicked in and when the traffic went back to the original path. So even though that the RSVP is not really a routing protocol, we can actually see near real-time tunnel changes because we have the integrated view of the routing, and we know, for example, if something happens with the IGP, like ISIS, OSPF, we know that, okay, I need to go out now and check the endpoints of that specific RSVP tunnel that might be affected. So we're using the intelligence of the routing to also detect a lot of things with traffic engineered tunnels. And of course, it's fully integrated with the IP layer and traffic information, so you can also see how much traffic is going in and out of each tunnel. So basically, these are the 4 key benefit areas of the route analytics solution. So it's faster problem resolution. So once you have a problem in your network, you can use the root cause analysis to see exactly where in the network did my problem occur. You get the real-time routing alerts, and you can see where the traffic is going. So if I had a problem in the network, I can see which links are my traffic rerouted to. So maybe one link cannot cope with that traffic, and you need to upgrade that link. So you can use that. You can use that tool with the problem in the problem resolution process. You can also strengthen your change management because you can ahead of time see what is going to happen with my network when I do certain things. When a link goes down, I maybe add another VPN network another VPN to my network. I may add a data center to my network, and you can see how that impacts your network. And that is also in the capacity planning, like we just saw from Peter Paul, with the peering and transit savings that EDPNet did in their network. They see exactly how much traffic they're sending to a certain AS, so they can make a decision whether to go to a direct peering or still keeping the transit peering for for this particular AS that they are sending traffic to. I think we have about 2 minutes, so if there are questions, feel free. Yeah?
So, I believe you have a huge dependence on net flow, right?
I can hear you, it's okay. Yeah.
All right, so I believe the solution heavily depends on net flow, right? Are there any other data sources that you may consider in your data processing, like, say, extrapolating from the visualization or something like that?
Well, right now we're doing net flow. We've had some plans of looking at other measuring things like taking SNMP information from the interfaces. But right now, and I think in the foreseeable future, which is like 2 years ahead, we will continue to use NetFlow.
Thank you.
We do support both NetFlow version 5 and version 9. So sometimes it's important to be able to take version 9 information if you have an MPLS network, because version 9 provides you with the MPLS labels. So we do support both of those variants. I think there was someone behind you there. Yeah.
Been answered by you just now.
Oh, okay.
Thank you.
Anything else? We have maybe you've seen the booth outside of here. So I will be there until about 4:30, 5 o'clock if you have additional questions that you want to ask, or if you're interested in some particular thing about the product. So, okay. Thanks a lot.